Hey, welcome back to another Moralis video. My name is Bharat, and in today's video, I'm going to be showing you how you can leverage Moralis APIs in order to build your own copy trading bot. So let's get started. So before we start diving into the code, I'm just going to give you a quick overview of various components that power our bot, and I'm also going to show you the bot in action. So let me just quickly open up Telegram right here. And as you can see, this is what we're going to be building in this tutorial. I'm going to show you how you can build this entire bot. So you can see that we've got all these messages that came from the bot. So it's basically saying that the swap has been copied, and you can see the network, the wallet that it's basically copying from. You can see the swap itself and the value as well as the transactions related to the swap. You can see that we've got the original transaction. This represents the wallet address that we're tracking and the transaction it performed. And you can see our transaction, which is the copy trading bot which performed this particular transaction. You also get the times, so you can see that we have got the time and the timestamp at which this transaction occurred and when it was basically processed by our crypto bot and executed. So you basically get this across all of the networks that our crypto copy trading bot supports. And as you can see, we are live on both EVM and Solana networks. In this video, I'm going to be showing you how you can actually configure your bot with Base and Solana. So I'm going to show you how we can actually copy trade and perform transactions on both these networks. And you can see that we have also got all these commands that the bot supports. So we have basically created a bot where you can use the /add command to add wallet address. You can remove, you can list out everything. You can also start the bot and stop it, etc. So we're going to go over various components of this bot, and we're going to see how exactly you can build this entire copy trading bot yourself. So let's get started. So I'm just going to open up my presentation here that kind of covers various components of our bot. So if you can see right here, our agenda is basically going over what exactly is some of the basics you need to know about copy trading bots and what are the components of our copy trading bot. And we're also going to look at the overall architecture of our application that we're going to build along with various APIs that we need for this. So all the data that you basically see related to the balances or related to the swap itself is all coming from Moralis, and we're going to see what APIs are actually powering up swaps, balances, and how we're actually going to use the Moralis RPCs in order to forward the transaction and execute them. So apart from just the API overview, you're also going to see how we integrate various dexes like Jupyter and 1inch. So these are basically DEX aggregators, and we're going to see how we integrate these APIs and basically add support for trading. So our bot is going to be able to execute or make trades by making use of these APIs. So the next thing after the trade execution is going to be the database setup. So in this tutorial, we're basically using MongoDB. So I've got a MongoDB Atlas setup, so I'm going to show you because that's really easy to get started. And I'm also going to give you a walkthrough of various schemas in our database that are related to our copy trading bot. After that, we're going to see the wallet setup, how you can actually set up your EVM and Solana wallets since they both have a different key standard, etc. What are some of the libraries you need in order to interface with these wallets, and how you can actually get your private key from either your MetaMask or your Phantom wallet in order to just try out this copy trading bot yourself. And finally, after that, we're going to dive into the code base and we're going to build this entire thing from scratch. So let's go ahead. And as you can see, if you're curious about what exactly is a copy trading bot, it's kind of like basically having a professional trader execute trades for you. So if there are basically a lot of wallets out there and you decide that, okay, there's one particular wallet that's making a lot of profit and you want to copy all the trades that is doing exactly, but you can't actually go into the explorer and monitor it every time whenever the bot whenever the actual wallet address makes trades. You can actually set up this trading bot, and with this you're going to have like automatic monitoring of those selected crypto wallets, and it's going to mirror the trading activity straight from your wallet. So it's basically like having a professional trader execute the trades for you because you're following some of the professional trader wallets out there. And what this can do is it's going to specifically look for token swaps, and it's going to copy them with the same parameters. So you'll also be able to customize this bot yourself So if you want to omit like certain transactions or certain tokens, and if you don't want to do like the complete transaction value and want to do like 30%, etc., it's completely customizable for you, because what I'm going to show you is how you can build this copy trading bot infrastructure and the overall application at a basic level, and you can definitely build your own enhancements on top of that. Apart from that, we are connecting this bot to Telegram so that we are getting a user-friendly interface where we can see all of the trades that the bot is executing, and you also get to see the performance of all these trades. So this is basically what a copy trading bot is. And moving on, some of the components of our copy trading bot are basically listed here. And the first one is the Telegram interface. So the Telegram interface is actually responsible for our communication with the bot itself. So as you can see, if I just put in like some commands, like I'm just going to do /help. And when I do this, you can see we've got some of the available commands. It tells us how we can add a new address that we want to copy. You can see remove, you've got list all tracked wallets, balances, status, etc. So we're going to use this Telegram interface because whenever the bot executes a swap, it's going to send a notification here so that we are always aware of all the transactions that our bot is performing. So that's the Telegram interface. The blockchain listeners are basically the Moralis APIs. So we monitor transactions across various chains using Moralis swaps API, and I'm going to show you how you can actually get your API key from Moralis and configure it to actually listen and track various swaps. And the next thing after the blockchain listeners is the smart execution engine. So here we are actually referring to what's actually executing these trades. So like we saw earlier, the execution is powered by 1inch, which is a DEX aggregator on EVM chains, and Jupiter, which is basically a DEX aggregator on Solana. So we're going to see how you can actually integrate their APIs within our application not to execute trades automatically. And after the execution, we're going to see database layer, which is, like I mentioned earlier, our MongoDB. And I'm going to show you what are all the schemas involved, what we're actually storing, like the swaps, the transaction history, etc. And the notification system is basically the successful trades and errors, the notifications you receive right here, that swap is copied, etc. In case there was like an issue where the swap could not be copied, you're going to receive a notification where it says, all right, you have insufficient funds, so you cannot copy the swap, etc. So you're going to get all of that right here. So that's the notification layer. And finally, the security layer is how we're actually managing wallets within our particular application. So we're going to go over all of these components before we get started. So let's go back to our agenda. So we have covered the components. The next thing for us is to actually look at the architecture. So I've just got a diagram here that kind of shows you the overall architecture diagram. So let me just zoom into this. So if you can see right here, the user is actually going to interface with the bot through Telegram. And what you see here is he can add wallet, he can use the commands in order to configure the bot itself. And if you look at some of the main components of the bot, you can see we've got the polling services. So what's actually happening in the polling services is it's going to make continuous API calls to Moralis in order to get the latest swap transactions for our across various wallet addresses and chains. So we have got our swap API, which is basically going to give us the swaps across EVM and Solana chains. So we're going to see how you can use the swap service in order to actually call Moralis APIs and store all these transactions in our database. So that's what you see right here. You've got like the swap fetcher that's continuously calling Moralis APIs and going to dump all the swaps on a database. Then you've got a swap processor, and what that's going to do is it's going to look at all the swaps that's coming into our database, and it's going to check and process them. So what I mean by process is it's actually going to replicate the trade itself. So we get data about the swap which our source wallet did, and our processor is going to look at that swap and it's going to execute the same transaction, and it's going to make use of basically our DEX APIs to do that. So as you can see, we've got the 1inch and Jupiter API. So these are going to make use, these are going to basically help us execute the swap on various chains that we support. So that's on the swap processor. We have the command handlers which are tied to our Telegram bot interface. So that's responsible for giving us responses to all of these commands whenever they're executed. And our MongoDB database contains data on the wallets that are to be tracked, and basically also contains all of the new swaps which are coming in, and also some basic bot level configs. So that's on the database side, and we're going to go deeper into all of these components. So at a high level, we're just going through the flow. So as you can see, we've got swap fetcher that's going to detect swaps from Moralis APIs, and it's going to dump it into our database. And we're making use of external APIs like the 1inch in Jupyter in order to execute the transaction. So what's going to happen here is it's going to call the DEX APIs, it's going to get the transaction, and once we've signed everything, we're going to forward this transaction to the relevant chain. Like what that means is we're going to push it to the RPC nodes, which are basically responsible for putting our transaction on chain. So that's on the execution services. We have covered the 1inch swap in Jupyter Swap, which uses the DEX APIs under the hood. And basically we also have the wallet services, and what this is going to be responsible for is basically interfacing with our wallets. So as you can see, we've got like our private key wallet that we have, and we're going to make use of the ethers.js library in order to create an interface with the private key wallet that lets us sign transactions, etc. And we're going to do the same with our Solana wallet, and we're going to use the Solana Web3.js library to do that. So this is a high level view of the overall applications architecture. So let's go ahead. So if you see what's next, we're going to see how we are actually getting all these swaps. So all that data related to the swap transactions, etc., for from the source wallet is all coming from Moralis APIs, and essentially Moralis APIs power our bot. So whenever our source wallet or the wallet that we want to track is performing any swap, we're going to get that swap data, which in a decoded format through Moralis APIs, and it's going to tell you all of the from address, the to address, the amounts, the transaction timestamp, the transaction hash, basically all kind of data related to the swap. You're going to get it with the Moralis wallet API. And after that, you have the token balance tracking. So whenever you try to execute certain commands, like let's say I'm just going to run a command, I'm going to do /balance, I'm going to put base. So when you do this, it's going to give us the balance of our wallet on base, and you can see I've got this much in native balance. These are all the tokens that the bot is holding. So you can basically get all of these wallet balances data as well through Moralis APIs. Apart from that, when you're performing any swap transaction, or it's your bot is copying a transaction, it needs to also forward that transaction to the relevant node, and that's going to use the Moralis RPC nodes in order to do that. So we're going to see how you can actually create RPC nodes on Moralis after you obtain your API keys, etc. And the next thing is you also get the portfolio data, which means you're going to get a complete overview on the address, the native balances, and the tokens, etc., for your particular wallet. And we are also cross-chain compatible because we have one unified API for all of the supported chains. So we're going to see all of these things soon. So let's go ahead to our next thing. So you can see next is basically related to trade execution. So maybe before I go into the trade execution, what I'm going to do is I'm going to also show you the APIs which are responsible. So to do that, what we're going to do is we're going to head over to docs, which is available at docs.moralis.com. So you can open up docs. So I've got it open right here. I'm just going to go to the main page. And as you can see, we've got all the API reference for all of Moralis APIs right here. You can see the popular APIs, wallet API, NFT, token, streams if you want to listen to real-time on-chain events, price API, etc. So to go ahead to our APIs that we need, let's basically click on EVM API to start with. So we're also going to look at the Solana swaps API. So once you're here in EVM, you can click on token API, and within token API, we have got token swaps. So within token swaps, we have got swaps by pair address, by token, and by wallet. And since our bot is a copy trading bot, we're basically copying trades of popular wallets out there, which are actually making a lot of money by trading. So we're going to use the get swaps by wallet API because we want to track the swaps of specific wallets. So once you're here in swaps by wallet address, you can see that this is the API that we're going to be calling in order to get the swaps. And it's deep index slash v2.2 slash wallets slash the address itself, and you've got slash swaps, and you have got the chain and order as well. So all of these is coming in the query params, and you can also further configure it. So if you want to see this in action, you can just get an API key from Moralis. You can just click on this and it's going to take you to our dashboard. Once you've signed in, you will be able to see your component usage, your API key. You've got links to our docs, tutorials, etc. right here. So once you've copied the API key, you can just directly paste it and use it for our application, etc. So we're going to see how you are going to set up our code base as well. And for that, we need our API key from Moralis as well. So if you want to try this out in our docs, you can either test live API straight from docs, but if you want to run it on terminal, you can just paste your API key here. So I'm just pasting my API key. You can see we've got the curl snippet, and I'm just going to open up, copy the curl snippet and open up my terminal. All right, so now we've got this, and let's just try running this curl command. So there we go. So you can basically see we've got all of the swap transactions that our wallet has performed. And if you look at this, you're getting the transaction hash, you're getting the index, the transaction type, you're also getting how much was bought or sold. You get the base token, code token, along with data on the USD prices, amounts, etc. So it's perfect for our use case, which is basically to build our copy trading bot, because we're getting all of the data on the wallet addresses, the token addresses, etc., for which we need to copy and execute the trades. So we use the swaps by wallet address API to do that, and we just saw how you can test it. You can either just test live API from the docs, and you can see all the swap transactions right here. And for the Solana API to get swaps by wallet address, you can just click on Explore Solana API, and once you do that, you'll be on the Solana API page. So we are right now in Solana API, and if you click on swaps by wallet, you can see we've got the API reference along with the sample response. So you can just test live API straight from here, and there you go. So you can see we've got our, this is the URL we're hitting. You can see the response contains transaction hash, the exchange, the base token, the code token, the bot sold, etc. So this is how we're going to monitor the wallet that we are tracking, and we're going to copy the exact trades that the wallet source wallet is basically performing. So that's on the swaps APIs. Coming back here, the next thing is the token balances. So in order to get the token balances, we use the get within the EVM API. You can go into get token balances, and you can see okay, right now we're in Solana, so you can see we have got the get native and SPL token balance by wallet. So we are using this API, and you can see I've got a sample address right here. So if you hit test live API, you can see that we get the native balances. We have got all of the tokens that this wallet is holding. You can see that we've got the amount it's holding, the same name, the symbol. In case there's a logo associated to it, you also get the logo and all of that data. So this is the API we use in order to actually return the response. Like when you're doing slash balance Solana, for example, it's going to make use of this API in order to retrieve the balances of the tokens, etc. So that's what we see right here. And for the same thing on EVM, we can just go into EVM API and go into token API. And once you're here, you can go into token balances, and we've got get native and ERC20 token balances by wallet. And this is the base URL for which you're hitting the EVM API for getting the balances. And as you can see, if you hit test live API, you get all of the token balances for this particular wallet, along with so looks like we're just getting some time for getting the response. So as you can see here, we've got all of the token balances. You've got the native token, you've got the portfolio percentage, you've got all of the token addresses, etc. So it's typically a lot easier for you to actually get all these token balances in just one API call. So this is what shows us the balances over here. So you can see we've got the wallet balance, you can see the chain, the address, and all of the token balances as well. So these are the Moralis APIs that we use in order to get the wallet data. So the next thing that we need to see is the RPC nodes. So once you're here in your dashboard, you can just click on nodes section right here. Once you click on nodes, you can see we've got all of the nodes. I've created all these nodes. So you can create a new node by just clicking create new node. Select a protocol, like I'm going to select base and I'm going to select mainnet. And once you click on create node, you're done. So once you've created it, there you go. So you can see we have got two nodes in base. So the first node is right here and the second node is right here. I already had one node, so that's why you see two here. And you've got two URLs which you can actually use as RPCs. So you can either use this or this, both represent the same thing. So you can just copy this URL, and depending on whatever chains you want to integrate our copy trading bot for, you can just copy those RPC nodes for those chains. So we just saw how you can create a node for base, and that's how you can actually create it for any protocol as well. So that's on the RPC node side. And we've also seen portfolio data, token balances, and the wallet swaps. So we can go ahead to our next section, which is on executing these trades. So as you can see, our trade execution is going to make use of Jupyter Ultra API, which is basically a new API offering that Jupyter has launched, making it super easy for you to integrate their swap functionality. And for EVM, we're going to use 1inch, which is an DEX aggregator for executing all of the trades. So this is on the trade execution side. So it's going to always take care of everything like best price routing, etc. under the hood, and it's going to find the optimal swap paths. Apart from that, we are using the Jupyter Ultra API, like I mentioned. You've got the 1inch API for performing the transactions or trades on EVM. And transaction signing basically happens with our wallets that we have. So we're going to see the wallet service, how you can initialize the wallet with ethers, etc. And that's going to sign all the transactions. And then you've got the direct execution feedback. So as soon as the transaction is performed or executed, you get this message on Telegram that's going to show us the links to the explorer, the value, etc. So that's on the trade execution. So now we can go ahead and look at what are the APIs on Jupyter and 1inch side as well that power our application. So I'm just going to open up Jupyter docs, and as you can see, they've got their docs at this URL. So you'll also be able to find all of the links I've referred to right here. So you can see I've got links to GitHub repos, the Moralis API, the 1inch API docs, etc. So you can just refer to this to go straight to our API docs, etc. So I'm on the Jupyter API docs right now. And as you can see, the Ultra API is like a new feature, that new API they've launched that lets you really easily perform swap transactions. And if you see, you've got like two major components. One is to get an order. And what this is going to do is it's going to give you the transaction stuff that you need to actually sign with your wallet. And once you have signed that, you can actually call the execute API in order to execute it. So if you look at this, the base URL is going to be this for the get order. And this is actually the API itself. So if you look at the params, you've got like the input, you can see the output, which is basically the two token addresses that we want to swap for. You've got the amount, how much you want to swap. Taker is going to represent the user's wallet address. And you've also got the referral account and referral fee. And we're going to ignore this because we don't really need any of this. So after that, you can see the response looks like this. You'll be able to get the aggregator swap. So that looks something like this. And once you get this aggregator swap, you're going to be able to actually assign this and pass it on to the execute order. And that's going to actually execute the transaction. You've also got the other format for the swap, which is the RFQ. And as you can see, you've got the similar transaction JSON right here. So once you get this, once you've signed it with our wallet, the next step is to actually call the execute API. And as you can see, we're going to call this URL, and you have to sign it. So you can see they're showing a snippet with Solana Web3 JS. you are basically executing the transaction, deserializing it and signing it. And once you have signed it, you convert it back and serialize it to base 64. And once that's done, you can pass in these two things into your request body of this API, and then you'll basically be able to execute this API, execute this swap itself. So that's on the Jupyter Ultra API, and this takes care of all the stuff like slippage, priority fees, etc. So you don't need to worry about all of that. And however, if you want to set your own slippage, etc., you can still like pass in your custom slippage value in basis points, etc., through the API itself. So we're going to see how you can actually integrate these APIs in order to execute the swap transactions. So now that we've seen Jupyter, we can go ahead and look at 1inch. So I've got 1inch as well right here. So I've got the 1inch dev portal open right here. And if you look at this, this is the docs for 1inch API. And the 1inch swap API lets us actually use the 1inch aggregator service in order to find the best route and execute our swap. And this is what we're actually doing as well. You can see we're getting all, we define our swap parameters and we call the 1inch API. So you can see the base URL of the 1inch API looks something like this, and we get the response. Once you get the response, you got to sign it from your wallet. And this example shows you how to do it with Web3.js. In our tutorial, we're going to actually use Ethers.js in order to do that. And once you have done that, you can basically broadcast the transaction. And what that's actually doing is it's using the ETH send raw transaction RPC method in order to actually forward the transaction onto the network. So this is on the how you can actually integrate the 1inch API to perform the swap itself. So you can check this docs out in order to learn how you can do this. So I'm also going to just leave a link to this as well in our YouTube video description so you can refer to it quickly. So now that we have seen this, we can go ahead and move on to our next part, which is our database setup. So for setting up your database, I'm actually using MongoDB Atlas because it's really easy and straightforward to set up. And as you can see, once you've signed into MongoDB Atlas, you're going to be able to see your dashboard, and you will be able to obtain your connection string and URLs, etc., by just using the MongoDB Atlas. And once you have set it up, you will be able to directly go into your project. And once you're in your project, you can see right here that I've got all the clusters. And what I'm going to do is I'm going to go into clusters. You can see I've got this particular cluster, and when you go into browse collections, you can see we have got these are all the collections that we have. So if you want to connect to this, you need the connection string for the database, and you can also just get that directly by clicking on connect. So once you're here on the cluster, you can just click on connect, and it's going to show you like how you can connect, etc. So you can just use the drivers, and once you've done that, this is actually the connection string. So you just got to copy the URL, replace it with your database password, and you're all set. So that's how you can actually set up your MongoDB Atlas and actually get it running for your particular application as well. So once you have done this, you're kind of all set. And the next thing is to actually go over all the schemas that power our application. So we are going to go over all of this step by step. So the chain schema is responsible for actually storing all the chain configs, I would say, like the Explorer URLs, the RPC URLs, the native token info like the decimals, the symbol, etc. That's all basically useful when we want to execute transactions or swaps with our APIs. The next thing is basically the wallet schema, and this is going to be responsible for storing all the addresses that are being monitored along with status and the metadata. So you're going to get like all of the stuff you see right here. So if you use /list command, so you can see these are all the commands. I'm just going to click on this, and you can see these are the currently tracked wallets. So it's the wallet schema is responsible for storing, okay, this is the wallet and this the chain, etc., like that, those kind of things. So we're going to go over the schema as well. And the swap schema is going to be responsible for storing all the executed trades of the wallet that we're copying from. So all the trades are going to be getting dumped onto our database. And like you saw in the architecture diagram, it's gonna we're gonna keep making calls to the Moralis wallet API, and all the swaps that come in is gonna go into our database, and from there it's gonna get picked up by the processor, which is actually gonna process and execute that swap. So that's on the database side for the swap schema. The next thing is basically configurations. So the bot configs like the chat ID, etc. So each Telegram bot chat is gonna have like a chat ID, and we need that chat ID because that's what tells Telegram where to actually send the message to. So we're gonna store all like basic configs related to our wallet on the config schema, and everything else is basically uh, set for our application. So we're also having indexing. So whenever you're querying like all the unprocessed swaps, we have like certain indexes on the wallet uh, collection so that you can quickly query for all the unprocessed swaps and actually process them. So that's on the database setup. And finally, I think we have the wallet setup. So the wallet setup is basically for all the wallets that we use for performing these transactions. So for executing all these transactions that we're copying from, we're going to put our wallet's private key on the env. So we have our server which is running, and we have the env file that actually stores the private keys of both EVM as well as Solana, and you're never supposed to commit your your env file, so you've always got to be careful about that. So since this is an MVP, we're going to show you how you can actually use the env in order to store like your private key, etc. And that's the wallet we're going to use for actually executing this transaction. So since it's an MVP, it's fine to keep your private keys in an env. However, if you're going into like a completely production grade application, then you should definitely check out like using some more secure solutions like HSMs, etc. So that's on the private key security side, and all the transactions are signed locally. So since our private key exists only on the servers, env, we're not sharing the keys. The keys never leave the server itself, and that's going to be responsible for signing the transaction, etc. So then you have the multi-chain support. So you've got one single interface and API for all the wallets, and you've also got the balance verification. So before every swap, we're going to just check whether we have sufficient funds, and that's going to ensure that we don't try to actually do a transaction when we don't have the sufficient funds, etc. And that's going to also give us custom errors. So that's really helpful if you want to like know why your copy trading bot did not execute a particular swap. You're going to get that reason as well, and it's going to tell swap failed, etc. So we also have that support within this, and you also have custom gas controls. If you want to set like transaction parameters like the gas priority fee, etc., you're going to be able to do that. So that's on the overall wallet setup. And to just give you a quick overview on all the files and architecture, you've got like the index.js, which is the entry point to the entire copy training bot. You've got like the Telegram folder that's responsible for all the stuff you see, like the commands, the responses you get when you call the commands, etc. And you've also got like various services like the swap fetcher. It's going to periodically keep calling and getting the swaps from all the wallets that we're tracking, and it's going to push it all of that into our database. And then we've got the swap processor, and that's going to actually take all of the transactions that's in our database, and it's going to actually process and execute them. And for executing them, it's going to use the dex aggregators like 1inch or Jupyter, and that's what we see right here. We have got like execution folder within services, and that's going to be responsible for all the execution. And finally, you also have like all the DB schemas and the models related to our particular database. And you've also got the wallets services, which is basically responsible for managing the private keys and creating the Ether.js, Solana Web3.js interface, etc., in order to actually execute or sign transactions on our server side. So this is basically a quick overview on all the key files and architecture. So we can actually go ahead and also just start building it. So as you can see, the next slides are all going deeper into each of the services. So you can see this tells us what the swap fetcher service is doing, the swap processor, you've got the wallet management, you have also got the swap execution, the Telegram interface, and these are the links. So these are kind of the main components of our application. And what we've seen right now is all the major components that are responsible for us in order to build this crypto copy trading bot. So let's get started into the code. One another thing that's important to note is basically for the Telegram bot itself, we're going to be using bot father. So if you're not familiar with bot father, it's actually a tool that lets you create a Telegram bot and get an API or a bot token. So with this Telegram bot token, you're going to be able to use your Node.js application or API in order to actually communicate and send these messages. So if you want to know how to actually get the bot API token from botfather, what you can actually do is you can just go into Telegram and you can search for like botfather, which I have right here. And once you're here, you can see that we've got this command called /newbot. So when you do /newbot, you can like name your bot. So I'm just going to name my bot, let's say testbot. So let me just do that. So there we go. So I'm just gonna do test bot. All right. Now you basically have to choose a username for your bot, and this username is gonna actually let you chat with the bot itself. So let's just pick some username. So I'm gonna call it copy trading Moralis underscore bot. So it needs to end with bot. So that's why you see this, and you can hit send. Great. So now the bot is actually created. And as you can see, you can configure the bot with like a profile picture, a description, all of that. And now you get this HTTP API token. So this is the token that you actually need if you want to send messages from your bot. So you need to copy this, and this is going to be used for our ENV, etc. within our app in order to actually send messages from our bot. So if I go back to our copy trading bot channel, as you can see, in order to send all these messages from the bot side, that's all going to come from our server, and our server's env is going to contain the bot father, bot api key token, bot api token, etc. that's necessary for us to actually communicate. So now we can actually get started building. And to get started, what you can do is you can just open up your favorite editor. So I'm just going to do that now. So I use cursor for my coding. So I've got my cursor ID open right here. And what we can actually do is we can go ahead and start opening up your terminal in which you want to have the project in. So I'm just going to go into my desktop. All right. And now I'm going to create an empty directory here. I'm going to call copy trading bot tutorial, and let's cd into this. There we go. Once you've done that, you can just open your cursor right here, the IDE. So now you can do this, and it's going to open up our cursor IDE right here. So now we have sorted out our IDE, and what we can do now is we can actually do npm init in order to create an empty npm repository here. So I'm just going to do npm init -y, and there we go. So you'll notice we get a package.json file right here, and here's where we're going to actually start building out our project. So the next thing is to actually install all the dependencies that you need for our project, and all of the dependencies you need, I've got it right here. And as you can see, you need Solana, Web3.js, you need Axios in order to make API calls. We're using the base 58 library in order to actually decode the private key. Basically, our private keys are going to be in base 58 format for Solana. So that's what you use this library for. And then you've got the .env, you've got ethers.js, which is for helping us interface with our wallet, which is our EVM wallet. And then you have got MongoDB and Mongoose for actually interfacing with our database. And Node Telegram bot API is what's going to let you actually make HTTP API calls with the bot API token that we just saw. And NodeMon's just for in case you want to have like a, without restarting your server, you want the changes and stuff, you can just use NodeMon. So now I'm going to install all of these packages. So let's wait for this to complete. All right, so now that we've got all the packages installed for us, we can go straight to our code base, which I've got right here, and we can start actually building out our application. So you can see our package.json now has all the stuff that we basically need. And what I'm going to do is I'm going to put in my env example file so that you can see what are all the variables that you need in order to actually run this project. So I'm going to create a .env.example, and what you can do is you can actually refer to this env example in order to know what are all the stuff you need. So I'm just going to paste this right here. So the first thing you need is your MongoDB connection string, and I've showed you how you can actually retrieve that straight from your MongoDB. So you can just go straight here, click on connect, copy your connection string, replace the password, and you can paste your key right here. Your Telegram bot token can be obtained from BotFather like we saw earlier. So we have got the bot API key token right here. So that's the token. So you can do the same thing and get the bot API key token yourself. So the next thing that you need is basically the Moralis API key. And we have also seen how you can get that. So you can just click get API key here. Once you've signed in, and on your home page, you can see the API key right here. Or what you can do is you can also just go into API keys section and create your own API key over there. So like you can see, we can just create it over there as well. So the next thing apart from this is the private keys. So for your private key, you can either generate a wallet on the spot by using the EtherJS library or etc. Or you can just do an easier thing because you need like a wallet that's kind of topped up with funds. The easiest way is to just like export out the private key from your MetaMask wallet or something. So that's what I've basically done. So I've exported my private key from both MetaMask and Phantom because you need a private key for EVM as well as Solana. So if you want to know how to export out your private keys, I'm going to leave some link that I find for getting your private keys, etc. So you're never supposed to reveal these private keys to anyone because these are what give access to all the funds that you have in your account. So you need to keep this really private and not reveal this anywhere. So that's something to remember. And remember to never commit your env file itself. So just as a safeguard, what you can do is you can create a git ignore file, and within the git ignore file you can just add in .env and also put in node modules because we never want to commit that either. So these are the two things you can just put into your git ignore. And once you're sorted, once you do that, you're sorted in terms of keeping your env safe. The next thing is your RPC URLs, which you can get from Moralis. So like I showed you, you can just go into nodes and copy your RPC URL straight from there. And these are the polling frequencies, which are in milliseconds. And this ultimately represents our frequency for which we're polling for new swaps. So new swap polling frequency represents how often do we call the Moralis wallet API in order to get the latest swaps. And swap processing frequency actually refers to how you can, what's the interval in which you want to call you want to process and look for all the unprocessed swaps from the database and process by executing them. So that's on the swap processing. And cleanup is just extra thing that we have added so that you can have your MongoDB database, you can prevent it from getting full. So but basically what happens in cleanup is every hour it's going to remove the process swaps, etc, and it's actually going to look at the threshold. So 24 hours means you're going to keep all the process swaps for 24 hours, but any swap that's older than 24 hours is going to get deleted. So that's on the cleanup frequencies, etc. And this is like a overall env that you basically need. So once you've actually put in your actual env in your file, the next step is to actually go ahead and start looking at all the schemas that we need for our application. So for this, what you can do is let's just create some overall structure for our repo. So I'm going to create an src folder. I'm also going to create a folder for scripts. So the scripts folder is going to contain all the scripts related to like initializing our collection with all the chain related configs, the bot configs, etc. So I've created the src, I've created scripts. So let me just look at what else we need. So this is basically all we need for now. And within src, what you can do is you can create a folder for config. So this config is going to be related to all of the configs which are necessary for the Telegram bot itself. And the next folder we can create is, we can create one for DB, which is our database, and we can create one for all the services. So I'm just going to create one for services. And once we're done with this, we can also create one for all the Telegram stuff. So we're going to create a folder called Telegram, and that's going to have all the files related to Telegram. Let me just zoom into this. Yep. So we've got all of this right here. And the next one is basically for wallets. So in order to initialize the wallet stuff like related to our EVM wallet or our Solana wallet, we need to use like the libraries like wallet, like ethers.js or Solana web3.js, etc. So we're going to do all that stuff within our wallets folder. And apart from that, we also need one for polling. So let's create one for polling, and that's going to contain like all the polling functions that we're going to use in order to call the Moralis wallet API, etc. And apart from polling, we also, let me just check if we have everything now. We also need models. So we need to put models within database. So that comes within database. However, I think at the outer layer, we have everything we need. So we can just create an index.js within this. That's going to be the entry point of all the stuff for our copy training bot. So now that I've created the index.js, we can go ahead and look at our database, what we need within it. And what we need is we can create a models folder here, and we're going to put all of our models within this. So I'm also going to add an index.js that's going to be an entry point for the DB stuff. So now we've got everything set. So within models, we can start adding all the models that we need. And as you saw here, if you go look at what are the database schemas you need a schema for the configs, the chain, the wallet, etc. So to start with, what we can do is we can start with a model for the chain. So I'm going to create a chains.js here. So let's do that. And I'm just going to put in my code, which I have here related to the chains config. So let me just paste this right here onto this. There we go. All right. So now if you look at this, let me just fix this. Okay. So we're making use of the Mongoose library, and you can see we've got the chain schema. The chain schema is actually going to contain the chain ID, the name of the chain, the type, whether it's an EVM chain or Solana. And this is helpful because we need to know which explorers or which wallets, etc. we need to use. So that's why we store the type. We also have RPC URLs. So the type also determines whether you're using like 1inch or Jupyter, etc. Different dexes depending on what you want to do. And you've also got the Moralis chain name. This is going to have the name based on the API request body that we need to pass. So if you look at the Moralis API, you've got chain parameter right here. So you need to have that chain specific chain name here. You've also got the explorer. So the explorer contains the explorer URL, etc. We've also got like the explorer transaction URL. So this is going to contain like how the URL looks with /tx slash the transaction hash. You've also got the explorer address URL. So for a specific address, like when you're, if you look at this, let's go back to our, let me just quickly open up our copy trading bot. So here we go. As you can see, we've got all the commands over here. And if you look at the Explorer address, so you can see right here, when we click on a wallet, it's going to take you to the address of that wallet itself and going to show you all the details about that particular wallet address. So for that, we require this that we basically see over here. So that's what this is used for in terms of getting and constructing those wallet address URLs for your address. And after that, you've got like some fields on whether or not the wallet is the chain is active, whether or not more details on the native token, like the symbol, the name, the decimals, and specific native tokens have specific addresses. Like if you want to look up like the address of the native token on ETH, you can see it looks like this. Similarly, different chains have different ways of uh, representing their native token config. So that's what we actually put in right here. And finally, we have gotten some properties over here related to the Explorer URLs. You've got Explorer address URLs. And finally, that's basically it. So this is the schema for chains.js. The next thing we can do is we can create our schema for our swaps. So I'm going to add in, so let's actually do our wallets first. So I'm going to add in tracked wallets, and this is going to hold all the this is the schema for all the wallets that we're actually tracking. So let me just quickly paste our tracked wallet schema that we have got. So there we go. So you can see we've got the address of the wallet we're tracking, the chain, the name, the description in case you want to have it. You've also got the whether or not it's active and when it was last checked. So these are the fields which we use for the tracked wallet schema, and timestamps. Basically, when you pass in this, you're going to get like the last created and the last updated field, etc. that MongoDB provides. We're also creating an index so that it's easier for us to look up. So we're indexing both address and chain. So it's easier for us to look up like all the wallets for a specific chain because it's now indexed. And you've also got like the finally you've got the tracked wallet model which is being created with mongoose.model, and that's basically on the tracked wallets. So now that we've got chains and tracked wallets ready, we can click and create our swaps model. So this is going to actually have every swap. So if you remember within our Moralis swaps API, so if I go into this and let's go into, let's say the token API, let's go into this. So this is the balances. So we need swaps, which is right here. Get token swaps, swaps by wallet. And if you hit Tesla API, you can see we've got all the transactions here. So basically for storing all this, you need to define the schema. And that schema is what is going to be defined right here. So if you go back into right here, let's put in our swaps.js schema as well. So I'm just going to paste the schema. There we go. So you can basically see we've got the schema right here. You can see that it's going to contain the source wallet information, the source chain, the source transaction as the timestamp, and finally you have the token info like the token in, the symbol, the name of the token, the amount, the decimal. So basically these are all the things we need in order to actually execute a copy transaction of that trade. So you need the token in, token out, and all the details related to that token for formatting. You're also just storing the USD value so that you can report. Like if you look at the messages, right, that are coming from the bot, you can see right here, we are reporting the value as well. So in order to do all of that, we store the USD value as well within this. And you've also got like the exchange information in case you want to show that as well. And this is the processing related info, like you're storing whether or not it's processed, you're storing the timestamps of processing. In case it's processed, you're going to get our transaction hash also here. So that's what we have in our transaction hash. And you've got like status as well, like depending on whether or not it's processed or whether it failed or completed, etc. And finally, we also have like all the indexes that we have for all the better query performance and querying everything. So that's on the overall swaps side. And finally, we can also just create our index.js right here, and we'll just put in the overall code. So as you can see, what's happening is we are going to connect to our DB using the MongoDB connection string. Everything happens right here within our DB's index.js. And this is what is necessary for you to actually create or interface with all the models. So that's what we have done right here. And the next thing for us to do is actually create a script so that we just populate our database with all the basic configs. So for doing that, I'm going to create a script called initdb.js. So let's just do that right here. And I'm going to put in the code I've got here for that. So there we go. So now the initdb.js is going to initialize the DB as you see right here with all of the chain related stuff. As you can see, we're initializing it with Solana, ETH, Matic, We're putting in like all of the transaction URLs. In case we don't have the RPC URL here, we're putting in public. So the public RPC URLs are always going to be much slower compared to Moralis RPC URL. So be sure to like put in your actual Moralis RPC URL in the env, so it's easier for you to actually not get errors a lot when you do these transactions. And finally, you've gotten like script in order to actually insert all of this into the collection that we need. So you're using the chain schema for it, and that's basically it. So if you look at the init bot config, we're also storing the bot configs into a separate collection as well. So I think one thing that we need to we forgot to add is the bot configs schema, because if you look at this, we need the bot config schema as well right here. So let's create the bot config model. So I'm just going to do that. So I've created the bot config.js. Let me just rename this. I've got to have bot config. Yep. So we're set. And let me just put in the bot config as well. So this is how the bot config looks. And this is basically customizable. So depending on whether or not or any new config you want to add, you can just add like the setting value description right here that allows for a lot of customization for configs. Like if you want to copy trade like just 30% of the actual value, etc., you could store it as a config on the bot and you're set. So now that we have got all of this, coming back to our initdb, you can see we're initializing some default configs, and that's basically to put in like bot status that's going to be running, and we're also putting notify on failed. And what this is going to do is, in case there's a failed transaction, you're going to get notifications on why it failed and that there was actually a failed transaction itself. So that's on the overall bot config, and these are the default bot config, and we're inserting all of that. So what we can do now is, since we have put in our env, etc., we can actually run this and have a look. So what I'm going to do is I am just going to run the script with node. So you need to have node for running this node.js script. So let's go script slash initdb.js. So now when we do this, it's going to actually run the script. It's connected to our connection string. It's initializing the collection. There we go. So now everything is inserted, and you can actually verify this if I go back to our database. So I've got MongoDB right here. Let's click on Atlas, and it's going to take us to our dashboard. So let's go back into project, and let's wait for this to load. All right, we have clusters right here. Let's go into browse collections. Okay, so now we've got like all the bot configs. We've got also the chains. So these basic chain related stuff we put in. So now we've got like some of the basic stuff we need in order to get started. We've initialized the database with everything we need. We have created the models. So what we can do now is we can start going into each of the services. So what we can do is, let's go into our services, or maybe before services, what we can do is we can go into our Telegram commands and all of that, so that you can actually try something out with our bot. So if you want to know about the bot that we just created, you can go back to botfather, and if you see, I gave this as the username. So I'm going to copy this because we need this if you want to chat with the bot. So you can just search for this now, and if you search, there we go, copy trading Moralis bot. This is the bot that we just created right here, and you can find it, which indicates that the bot is actually created. So we're not going to do anything as of now. So I'm just going to go back here and go back into botfather. And what we need to do now is we can actually create the Telegram commands and stuff. So we're going to go into Telegram, and we're going to create an index.js file that serves as an entry point. So I'm just going to do that. So I've created the index.js, and I'm also going to create like a commands.js. So this is going to contain all of the commands, and we're also going to put like messages.js, which is a file that takes care of all the formatting for all the messages that goes out. So now we can start with index.js for Telegram, and I'm going to put this in right here. So if you look at what's happening here, you can see that it is actually requiring the models botconfig.js right here. Not sure why we're getting an error here. So all right, so if you restart your code editor, it's going to go out because it's still detecting the old one. So let me just quickly restart my code editor. All right, so there you go. You can see that now we've got the error gone out. And if you look at this, this is the bot instance that we're creating, and we're actually making use of the Telegram bot API. So if you see, we're using the Node Telegram bot API, and based on the documentation of that, you've got to create a bot instance right here if you want to send messages. And you can basically initialize the bot right here with this message. So if you look at what's happening, we're registering command handlers. So these are all the commands that we're supporting. And every time there's an incoming message that comes in, so you can see we're only going to respond to messages that start with a slash, which means you need to actually talk to the bot via the commands. So if you look at this, we're handling the incoming messages. These are the known commands. In case it's not known, we're going to say unknown command, and you need to actually use help to use the available commands. So once you've done that, it's going to check if you have a stored chat ID. In case it's your first time like talking with this bot, and it's going to actually store the chat ID. So if you look at what's happening within the start handler, so maybe before we go into handlers, let's complete this. So you can see we're just checking whether or not we have the chat ID, and you also have a function to retrieve the active chat ID from the database. So you can access that by just going and doing checking within our DB. So from the database, if we have already stored the chat ID, we get that. But in case the user does not want to use that chat ID, you can explicitly hard code your chat ID within your env and save it as a env variable. So and what that's going to do is it's not going to look at the database. In case it's not there in the database, it's going to use this particular admin chat ID that we have in our env. So what we're going to actually do is we're going to have the env, we're going to have the chat ID stored in the database itself. So it's going to read that and it's going to use it for all of our operations. So we don't really need to store this in the env. So this is just in case you want to do this. So now that we have got this set, what we can do is go into commands, and let me put in all the commands that we have right here. There we go. So now if you look at what's happening in the commands is we have a function that's going to help us store the chat ID on the database. And what this is going to do is it's just going to put this as a config onto our database. So if you look at this, it's going to create a new config called chat ID. And like I said earlier, this config schema is where you put in like any kind of configs you want related to your bot, like any custom settings you want, etc. And that's perfect so that you can seamlessly interface with your bot settings. So that's on the config side. Then you've got the command handlers. So these are all the handlers. So if you look at this, we've got start. So this is the first time you chat with the bot, you're going to use the start. And that's what you see like when you go and search the bot itself, it shows a button over there called start. And that's the command it uses. So it's going to actually store the chat ID upon the first interaction with the bot. So this is the chat ID it's going to use for all such communications after that, because if you see, it's reading the chat ID from the database from for all of the other stuff. So that's what we do right here. We store the chat ID on the database, and you get this custom message that welcome to the Telegram copy trading bot. You can do all of this, etc. And it shows you all of the known commands, etc. that you can use. So you here we have basically defined for each of the commands their respective handlers. So add wallet is going to store in the database the wallet address itself. So if you look at this, what's actually happening is it's going to store the wallet which we are which we have actually extracted. So if you look at this, it's going to check first if the wallet already exists. In case the wallet exists, it's going to just say that. Otherwise, it's going to insert that into the database itself. So what you see here is create new tracked wallet, and it's going to add a new wallet, and we're going to see how you can actually do this as well. So this is on the adding a new wallet side in order to create a wallet. And if you go here, this is the same thing, but to remove a wallet, you're going to actually delete the entry from the database, etc. So that's what you see. You've also got soft delete. So you just set the active status to false. So it's not actually deleting it completely. However, you can actually modify this if you want to actually delete it as well. So next is to list wallets, and this is going to actually call the format wallet list function. Is going to list all the wallets in the UI like we saw earlier. So that's on the format wallet list. Then you've got the status. The status is going to put in like this, give us a status update on our bot itself, whether or not it's running, how much wallets it's tracking, how much chains, etc. So that's on the status. The balance is for fetching the balances. And what it's going to do is it's going to call the Moralis API. And you can see we've got get EVM balance and get Solana balance as well. And it's going to use those methods in order to actually get the balance. So if you see here, we're getting these from the wallet implementation. So within wallet, we're gonna have the EVM wallet as well as the Solana wallet. So over there, we have all the functions related to our wallet, like the Ether.js, etc. So that's all goes straight into that. And finally, if you see, you've got the format balance message, and it's just formatting that, and you've got the wallet list. This is the function that's responsible for like showing you all the list of wallets in a neat format. So that's basically it on all the commands. So now that we have got like the index.js and command setup, we can go into messages.js and also create the other utility functions or helper functions that we need for various things. So you can see we have got a lot of functions here. It's just related to formatting addresses. You have got get transaction URL, and this is just going to like get all the transaction URL, address URL, the default explorers, the formatting numbers, etc. And all these are just utility stuff, which is useful for like showing the stuff. Like if you go into the bot, you can see this is all shortened. You can see we've got the decimals all handled, etc. All of that is basically configured within this messages.js. It just takes care of all those things, and that's basically it. So now that we've got all the Telegram stuff complete, we can go ahead with setting up all the wallet stuff. So if you go back to our slides right here, you can see that we've got wallet setup, which is basically for setting up with EVM and Solana wallet. So if you put in your private key, like I mentioned in your ENV, so what we need to do now is we need to actually use Ether.js or Solana Web3.js in order to create an interface so that your wallet is going to be able to sign transactions, etc., in order to execute or perform these transactions. So what we're going to do now is we're going to create the wallet related stuff right here within the wallets folder, and I'm going to create a file called evm.js. So let me just do that right here. And I'm also going to create a file called solana.js. So this is for the respective wallets. So let's start with the EVM one. So I'm just going to put in the code I have right here. And if you look at what's happening here, what we're going to do is we're basically importing the Ethers library, and then you've got Axios in order to make API calls. And if you look at this, we have got the ERC20 ABI right here. So the ERC20 ABI is basically so that whenever you perform a particular swap transaction, you're going to directly use the 1-inch router in order to do that. So since 1-inch is a DEX aggregator, and in the typical way in which you want to swap EVM ERC20 tokens, you need to have the approval made in place. So basically, if you want to swap a token A to token B, you need to approve the router, 1-inch router, with a specific allowance of token A so that it can actually perform the swap. So since approvals are basically required, we need to have the ERC20 ABI. And whenever there's a lack of approval, what's going to happen is it's actually going to call the approval function, approve the limit of tokens. So I believe that we've set infinite approval right here, although a better format would be to actually approve just the specific number of tokens you need. So this approval is going to be actually called, and once you've done that, you're going to actually approve the 1-inch router to perform the swap for you. So that's why you have the ERC20 ABI right here. So apart from that, you've also got the EVM provider, you've got the EVM wallet. You've also got what's actually happening in EVM provider is it's creating a provider interface using the Ethers.js library, and that's what you see right here. And EVM wallet is going to return the wallet itself, like the Ethers interface of the wallet. So that's what you see, ethers.wallet, and that's where you use the response you get from this function EVM wallet is what you use now for signing transactions, etc. So if you want to retrieve like the token balances for EVM, Like we saw earlier, we're going to be using the token balances API. So let's go back to EVM API. Within that, you've got token balances. And this is the API that we're actually integrating right here in order to retrieve the token balances. And this is what is used whenever you are running the commands and retrieving the wallet balances. So that's what you see right here. And apart from that, you've also got the native token. So if you see here, you're finding out the so what's happening here is you're finding out the native token and the other tokens, and you're basically retrieving the native token wallet balances in order to show in this particular format. So that's what you see right here, the native balances and the token balances. So apart from that, we also have the approve token function. And what it's going to do is it's going to call the approve function, which is present here. So you've got the function approve, and this approve token is going to call that for your ERC20 contract. And it's creating the approve transaction right here. We are basically doing an infinite approval right here because we don't want to actually keep doing these approval transactions a lot because they cost gas every time. So that's what you do right here. And you've got like the approval transaction sent. And in case there's already the allowance existing, you're not going to actually even do the approve token. So that's what's being done here. And we're exporting out all these functions in order to be used within our execution module. So now that we have created the evm.js, we can go ahead and create the solana.js. So I'm just going to put in my solana.js as well right here. There we go. So now if you see what's happening, it's using the Solana Web3 JS library. And what it's going to do is it's going to make use of the base 58 package. So earlier we were using the BS58 package, which led to errors. So you can just use the base 58 in order to decode the private key, etc. and to use within the application. So now you've got like the necessary libraries like Axios and ENV, and this is where the Solana wallet is created with the private key. So if you look at what's happening, we're reading the private key from the ENV, and we are converting the base 58 private key to a uint array, and from there the key pair is actually created, and this key pair is what is used for actually signing transactions, etc. So we are creating a Solana connection in order to like talk to the Solana RPC and get the native balance, etc. So you can also use the Moralis API if you don't want to do this. You'll directly get all of the token balances and RPC as well. So this is the part where we are, we just close this. So this is the part where we're actually getting the Solana token balances and native balances as well. And for that, the API that's being used is Solana API. Let's go to token, and there we go. So get wallet portfolio is actually going to retrieve all of the token balances and the NFT balances for a given address. So this is the API that we are using right here, and it's actually going to give us all of the balances data for us. So if you look at this, this is the actual function get Solana balance, and what it's doing is actually it's calling the portfolio data from calling the portfolio API in order to get the complete portfolio balances. So that's what we're doing. We're iterating through the portfolio tokens and getting all of that data for our execution. So if you look at what's happening finally, we're exporting out all these three functions that we just saw. And you now have get Solana wallet, which is going to give you the key pair instance, letting you sign transactions. You've got the Solana connection in order to like, if you want to do any RPC stuff or query balance, etc. with your Solana node. And you've got Solana balance itself, which is a function that's just calling our Moralis API and giving you all these balances. So now that we've got all the wallet stuff set, we can go ahead and actually move to our next thing. But maybe before we go further into implementing this, what we can do is we can actually look at our existing implementation that we had right here and actually try this out so you can see this in action, perform a particular or copy a particular swap. So that's what we're going to do now. And we're going to use the copy trading bot to actually make a transaction for us. So let me just quickly clear out this particular chat here because we don't need this anymore because we're resetting everything. And I'm also going to start my server from the previous one that we just saw. So I'm just going to start this. And right now what we're doing is we're not running the application that we're building right now. but I'm just running this so that I can show you how the copy trading is actually happening in action. So now that we have it all running, if I click on /start, what's going to happen is it's going to do the welcome to the Telegram copy trading bot. You can see /help. It's going to give us all the commands. If I do /list now, it's not going to show us any wallets. That's what you see right here. And to start with, what we're going to do is let's add a wallet, Solana wallet to track. So we'll test both EVM and Solana flow so you can actually see the bot in action. So let me just start with the Solana wallet right here. And let me enter in my password. There we go. And let's decide which wallet we want to track. So I'm just going to copy this address and let's actually track this particular wallet. So I'm just going to put this, paste the address, and I'm going to name, put in the chain as well. So now what's going to happen is it's now tracking this wallet. So now that we've added a Solana wallet to track, let's go into our next thing, which is to track an EVM wallet. So I'm just going to copy this address and I'm going to track this on Base because Base has really good, uh, really low transaction fees. So which makes it perfect for us to test. So I'm just going to do this and let's add Base. There you go. So now it's tracking on Base, and you can kind of confirm this because if you go into our database, so you can go into MongoDB and let's refresh this. You'll actually be able to see all the things. Because the first time you do start, you're going to actually store the chat ID. That's what you've done right here. And this is the primary chat ID which you use for all the notifications. And that's how it's been actually talking to us as well. And now if you go into like tracked wallets, you can now see the two wallets that we tracked right here. You've got Solana, you've got address, you've got base, and you've got the address as well. So now that we've got it all set on the database side, the next thing is to actually try doing a swap itself. So what we can do now is let's actually just look up the balances so that we don't run into issues while performing a swap. So I'm going to go into /balance base, and there you go. So now you can see it's got this much native balance. You've got these tokens as well, and it's got like CBBTC, all of that. So maybe what I can do is I'm going to try swapping CBBTC into ETH. So that's the transaction I'm going to try. And for that, I also need to ensure I've got CBBTC here. Yep, I've got CBBTC. So now we can just open up any DEX you want. So I'm just going to open up Uniswap right here. And as you can see, I'm going to switch into CB Bitcoin, Coinbase Bitcoin, and let's put in a certain value. All right, so maybe what we can do is we'll just convert CBBTC to USDC, and let's convert 0.001. All right, I need to go even further. Okay. Okay, now we've got to 4. So now 3. All right, so now it's going to be, you can see right here, the amount is just $1.93. And you can see it's converting CBBTC to USDC. And this is the amount. So you can also ensure that we've got that sufficient CBBTC in order to do this. So now that we have all set, you can actually review the swap, and let's actually do this, approve and swap. So I'm just going to approve this. There we go. And I'm just not going to do unlimited because it's always better to just approve a smaller amount. So I'm just going to do that and confirm. So as soon as the approval is done, you're going to get another pop-up to sign the message. So let's wait for this to complete. There we go. So now it's done. Now you've got the spending cap request. Let's confirm this. And finally, we need to confirm the swap. So there we go. So now that we have done this, let's hit confirm. And now let's wait for this transaction to complete. You can see right here, we've got the Explorer link, and there you go. So now this is basically successful. So what's going to happen now is our bot is going to run the, is going to query every certain seconds, and it's going to find this transaction, and it's actually going to use the 1-inch router to execute it. So looks like we had some issue with insufficient balance. So let's try to see what happened here. All right, looks like we have found what the issue is actually. So it looks like it's basically an issue related to just the decimal formatting. Well, the actual balance right here, as you see, was supposed to be 0.009560. But while actually performing the transaction on the 1 inch, we actually checked the balance, but we did not format the decimal properly. And now, since the issue has been solved, you can see right here that we have got swap copied. And if you want to check this out in real time, we can try out a swap actually right now. So what I'm going to do before that is I'm going to just look at the balances. So let's look up the balance in base. And if you try this out, you can see we've got 10 USDC, you've got this much CBBTC, you've got this much native balance. So what we can do is we can try swapping USDC into CBBTC. So for that, let's go back to Uniswap right here. So I've got Uniswap over here. And what we can do now is we can just open up USDC on base, and let's put in, like, let's say just 2 USDC, because we have 10 here. So now we're going to buy 2 USDC worth of CBBTC. So if you hit review now, we can just click on swap because we have already done the approval stuff. And now we can hit confirm. So as soon as you hit confirm, let's wait for this transaction to complete. And at the same time, I'm going to open up my Telegram as well, so we can see the transaction actually come in. So let's wait for the swap to be processed. You can see this transaction was confirmed. And now what's actually happening is it's trying to do our transaction using the 1 inch router as well. There you go. So now you can basically see that this is how fast our APIs are actually, because we immediately found out the swap got confirmed on chain. And right after that swap was performed, this automatically executed the same swap. And as you see right here, we have swapped to USDC to Coinbase Bitcoin. And you can view this transaction by just opening this up. So this is the transaction that our bot just did. You can see the address is different. And if you open up the source transaction, you can see it right here. This is placed by my primary address. So that's how you can actually visualize the copy trades actually happen in real time. And if you look at the wallets which are being tracked with the /list command, you can see we are tracking 2 wallets, Solana and Base. And now we've seen how, like, you can copy trades with the bot on Base. So let's look at Solana. And to get that started, I've basically ran the balance command right here on the Telegram bot. And as you can see, it's showing us our native balance and the balance of all the tokens that we have right here. And what we can do now is, since we've already configured to track the Solana address like we saw earlier, I'm just going to /list. And as you can see, we've got the Solana address right here that we're already tracking. We can basically go ahead and try performing a swap with that. So based on this balance, you can see we've got sufficient Sol, we've got sufficient amount of these tokens. And what I'm going to do is I'm going to head over to Meteora. So I'm just going to open that up right here. And let's go into pools. And once we're here, let's go into dynamic pools and let's just pick something from this. So I'm going to choose, let's just search for Sol. Let's probably just go with virtual Sol. And over here, if you see, I'm going to swap between Sol and virtual. So I'm actually buying virtual tokens. So let's do this. And if I hit swap right now, what's going to happen is it's going to confirm the transaction on my Phantom. And once we confirm this, we should soon receive a notification that the swap was actually performed. So let's just wait for some time. And this actually has to get picked up by our Solana swaps API. So you can see right here, we are on our Solana swaps API. And this is the wallet address that we are tracking, BXHP. So let me just open the Telegram and let's see in case it processed it. If you hit test live API now, you can see this is the transaction that we just did. So we should receive our swap pretty soon. So if you see right here, this was the USD price, this was the sold, and there you go. So now you can see the swap was copied, and what we just saw is how you can actually use the copy trading bot in order to perform swaps on both Solana as well as EVM chains. So now that we've seen this, we can go back to our code base and continue building the rest of the parts that we need. So let's go ahead. And the next thing to implement for us would actually be the polling itself. Like we saw earlier, if you go into the polling section right here, you can basically see that the swap fetcher is responsible for detecting new swaps. And what it's actually going to be doing is it's going to be calling the Moralis swaps by wallet API, and it's going to retrieve all of those swaps and insert it onto our database. And we have a separate swap processor that's going to process all of these pending swaps. So once the swaps get processed, it's going to actually call the execute, and it's going to either call the 1-inch DEX aggregator or the Jupyter aggregator in order to actually execute these swaps. So the next thing for us to implement would be like the polling itself, which is going to have both for EVM as well as Solana swaps. So let's go ahead and start implementing that. So for that, what we can do is let's create a folder within SRC called Moralis, and this is going to contain within services. Let me just check again. So it needs to be within services, and we need to have a folder called Moralis, and that's going to contain all of the EVM and Solana API calls. So I'm going to call and have a file called EVM swaps.js, and let's also have a file called Solana swaps.js. All right. So these are the two things we need. And over here, we're going to actually call the Moralis EVM swaps by wallet API. So I'm just going to paste the code right here. And as you can see, we are calling the EVM API, and we're actually taking all of the swaps and storing it in our database. So we're getting the normalized swap format, but so this is just exporting the function where we're calling the EVM swaps and Solana swaps, and the actual storing will happen within the polling service. So the polling service is going to have the swap processor, and it's also going to have the swap fetcher. And within the swap fetcher, we're going to actually use this. We're basically exporting out this function right here. As you can see, we're going to use this within that, and we're going to actually store all the swaps. So if you want to see what's happening right here, all that's happening is it's going to call the EVM swaps by wallet address API, and it's going to actually store it. So that's what we're doing. We're basically formatting this so that we fit all of these fields based on a swap schema. So that's what's happening over here. So the next thing is basically for Solana swap. So let's do the same thing. So I'm just going to put in the code, and as you can see, we're calling the Solana API this time. So like we saw earlier, we have the swaps by wallet address API for EVM and Solana. And this is what we're actually using right here in order to fetch all the swaps for a Solana wallet. And this is again being formatted in the specific schema that we need before we actually dump it into our database. So that's what we're doing right here. We've got like some helper functions in both this and this just to help out with the decimals. So in case that we don't know the decimal, we're defaulting it to 9. So that's on the Solana swap side and EVM swap side. So we can go ahead and start implementing our polling. So I'm going to name this file swap fetcher. So the swap fetcher is going to fetch all the swaps and going to insert them into our collection. So let's do the same thing. And I'm going to also do swap processor.js. There we go. So now we've got swap fetcher as well as swap processor. And within swap fetcher, what we're going to do is we're going to use the EVM and Solana swaps. So as you can see, we've imported both of them, and it's going to fetch new swaps depending on the chain. So that's what we're doing. We're grouping it by chain, and based on the chain itself, we are basically making an API call in order to get all the EVM and Solana swaps. So in case it's EVM, we're going to call the EVM API with the respective chain. In case it's Solana, we just directly make the call to the Solana swaps API. And once we get all of the swaps, if you can see right here, based on our description, we are filtering swaps only for a recent timestamp. So we don't want to process or even take in swaps which are really old. So we're just taking it in the recent window. That's one condition. And the second condition is we're also filtering it only after the wallet tracking began. So in case you just started tracking, you don't want to copy trade all the old swaps. So that's what we're also doing. So if you see, we have the time threshold that's being done here, and we're also filtering to only new swaps and based on the tracking start time. So what we're doing is we're checking the time at which this wallet was added into the database for tracking, and we're using that as a tracking time in order to determine whether or not to copy a particular swap. So that's on the swap definition for the wallet tracking. And then you have like a summary in case new swaps are found. You're going to receive in our terminal, we're going to do swap fetching completed, and it's going to say how many swaps were added newly. So these are just utility functions in order to start and stop the swap fetcher functions. And this is basically going to not, it's going to not work unless we have the bot running. So you have the bot state, which is basically fetched again. So you can see if is running is uh, false, then it means that it is basically running. And if it's running is true, it means that the bot is running. And that's what we basically have right here as well. So that's on the thing. In case it's not running, we're just returning it, and everything else basically gets processed. So this is on the swap fetcher. So now we can go ahead to our swap processor. So this is what I'm going to do. I'm going to open up the swap processor as well. And what's happening here is we're actually fetching the unprocessed swaps. So if you see what's happening, we're first getting the chat ID from the database, and we have this function right here, send notification, that's responsible for sending notifications as well. And you can see right here, we're logging it in. And this is the important function that we need, which is process swaps. So process swaps is actually going to fetch so all the unprocessed swaps based on the pending state. So you can see that we're making a query to our Mongo collection, and based on processed, false, and status code pending, it's going to get all of those swaps. And if you see, it's going to process all of those swaps one by one. So while it's processing it, what it's actually doing is it's going through each swap one by one, and it's going to call the execute stuff. So we either have execute one in swap or execute Jupyter swaps depending on chain. And once that's done, we are calling the send notification function in order to actually send the notification that the swap was successful. So that's on the overall side for fetching and messaging the Telegram channel with whether or not the swap was complete. In case if it was failed and the notify on failed is set to true, then it's going to notify the failed transaction as well. So that's on the overall swap summary as well that gets printed in the terminal. And you've got some utility functions in order to start and swap the processor service. So now we are basically seeing how the swap processor and swap fetcher service works. So the next thing is to actually go ahead to the swap execution. So if you see the swap execution, you've got the 1-inch integration where we call the 1-inch API in order to actually execute the swap for EVM. And similarly for Solana, you've got the Jupyter integration where we call the Jupyter API to execute the swaps. So we need to define these functions within the SRC services. So let's go back here, and within polling, we've got services right here. And there you go. So the next step is to actually create the execution folder. So there is one thing, which is the polling is supposed to be under services. So let's ensure that it's all coming within that. So you've got polling, you've got Moralis, Telegram is also supposed to be in services. And let's update the imports, and let's also do the same with wallets. So once we have done that, we're all set. And the only thing we need to now change is we need to create the folder for basically using our execution module. So I'm going to create a folder called execution, and within execution we're going to have the 1-inch swap as well as the Jupyter swap. So I'm going to create inch swap.js, and for Jupyter I'm going to create Jupyter swap.js as well. Okay, now that we have created both of them, I'm just going to open up the in swap which I've got right here, and let's go through our code if you see what's happening. So like we saw earlier with the 1-inch docs, so if you go back to our docs of 1-inch which we have got right here, you can see that we're going to make an API call to this endpoint. So it's basically api.1inch.dev /swap/6.2. So this is the endpoint you need to use if you want to make the swap. And that's what's actually happening over here as well. So if you go one by one, you can see that the execute in swap function is the main function that we need, and it's doing some basic checks in order to check whether or not it's a native token. And once you've done that, we need to retrieve the 1-inch router address, because we need to check if we have approved that 1-inch router address with the specific ERC20 token we're swapping. So that's what's happening right here. We're making a call in order to check whether or not we have basically have approved. So you're first checking the sufficient balance for the swap. Once you have decided that there is sufficient balance, the next step is to check whether or not you can interact with it, which you can do by just making a call and getting the symbol. So in case you get it, it means that you've been able to interact with it. And the next step is to actually check the balance and the required amount. So you can see we have checked the balance and how much is required, and we are comparing the values in order to check we have got sufficient balance. And once that's done, you can see right here, the next step is to actually check the approval like we discussed. So the approval is going to check whether or not we have approved the 1-inch router address. And once all these steps are complete, that is, you've got sufficient balance, you have approved the 1-inch router, you're basically good to perform the swap. And for performing the swap, we are calling the 1-inch API URL, and this URL is going to return us the transaction parameters, etc., which we need to sign from our transaction. So what we get is the response contains all of the stuff that we need to sign. So we're extracting out the swap data field, and this is the transaction that we basically need. So we're creating the transaction right here, and as you can see, the data field contains the swap data which we got from 1-inch, and the only thing we need to do now is actually sign it. So we've got the transaction, and now we are basically doing wallet.send transaction, and this is actually going to directly perform the transaction. So this is what's going to put the transaction onto our relevant RPC node, and send transaction is going to use the RPC method in order to do that onto the hood. So once we have done this, we are just handling some errors in case that there is some error with the 1-inch swap. So that's what you see right here. And we've got some helper functions apart from the execute in swap. So you've got like the whether or not it's a native token in order to check. And you've also got check and approve allowance, which is basically going to be called when the allowance check fails. So in case that you don't have sufficient allowance to the 1-inch router, you're going to call the check and approve allowance, and that's going to actually give an infinite approval of allowance uh, to our particular 1-inch router in order to perform that particular transaction. So now that we've got almost everything ready, we've got execution service. Let's just check if we have got everything. We've got the Moralis swaps function right here, which is actually being used in the polling. So we've got the polling as well ready. We've got the Telegram as well ready with everything we need, and that's also done. So the Telegram is supposed to be separate from services. So let's move it out into just SRC. So let's update it again. So the previous one was actually correct. And now you've got services. Now you've got Telegram. Within services, we have got the execution service, the Moralis, the polling, and wallets, so which we have all set up. And Telegram is going to contain interfacing with the Telegram. It's chat UI. So that's it as well. And let's see if we have completed the index.js. So index.js is needed because that's what's going to contain all the functions related to starting the bot. So if you see right here, I've pasted in the code, and it's going to take in certain things like the config, etc. And it's going to initialize the Telegram bot and start all the services. And finally, you've got start the bot. So this is actually calling the function here, which is in turn calling all the sub services within it. So that's what we've got index.js set up now. So we've got Telegram as well all set up. So we just need to create a cleanup.js file, which will also go within our SRC. So let me just create a cleanup.js. There we go. And what's going to happen in cleanup.js is it's going to be responsible for cleaning all the process swaps, and it's going to retrieve all the intervals from our env. That's what you see, and you basically see that it's deleting all the older swaps which are greater than our intervals that we have set on our ENVs. So now that we have got our cleanup ready, we've got the config. So let me just check. All right, so the config is pending. So we need to create the index.js within config. So that's going to basically load everything from our env and keep it in a config that we can access throughout. So if you see this, this is what's going into our config. You get all of the frequencies, the validations, etc. happens right here. So now within all the functions, you can just access everything with config dot, etc. So that's what we have done for the config. So now we've got almost everything ready. As we can see, we've got the database models, we've got the index.js as well ready, and we've got the services as well. So the services has all the four things we need, and we've also got the Telegram related stuff handled right here. So we're basically almost done, I would say, in order to actually try this out. All right, so now that we've added all the files that we basically need, what we can do is we can actually try running our application and trying it out. So for this, I'm just going to open up my existing code base, and let me just bring it onto screen right here. There we go. So now if we enable this right here, what we can do is we can just use the command npm start, and you should be able to see the copy trading bot running. There we go. So now you can see that the copy trading bot is all running, and we have got all of the components necessary initialized, like we've got no active wallets to track. We have swap fetcher is started with the polling frequency. You can also see the cleanup, and you can also see there's no active wallets tracking at the moment. So in order to get started, what you can do is let's go ahead and try to initiate a conversation with our bot. So I'm just going to open up the slide again, and now I've got Telegram here, and let's search for the let's just open up botfather again quickly, and let's see. Here we go. So this is the bot that we just created, the username of the bot we created. So if you go back here and search for this, you should be this isn't the one. So let's just go back, search here. There we go, testbot 123. So this was the one we just created. So if you hit start now, it should actually listen to this. There you go. So now you've got the storing new chat ID, and you've also got the response. So now you can basically see that it works. And if you do /help, you can see that it again recognized it, and you've got the chat ID, all of that. And what we can actually do now is we can start trying things out. So what we can start with is, let's try, for example, the balance API. So what I'm going to do is I'm going to run /balance, and I'm going to do Solana. So now we're going to get the Solana API being called of Moralis. You can see right here, it's found 4 tokens. You've got the native balances as well, and the addresses. So you can do the same thing and check the balances on base. So if you do this, you should get the balance on base. There you go. So now we have set and we have tried the balances. So what we can do now next is you can just add the wallet address that you want to track. So I'm going to do /add, and I'm going to add this wallet I have right here onto MetaMask, onto the Telegram. So I'm going to do this and I'm going to call it base. So now we have set the chain and the wallet address we want to track. And if you go here, you can see that right now it's on no active wallets to track. But if you see, it's going to say that it's tracking one wallet. So we should see that soon coming up. So now what we can do is let's also add the Solana wallet. So I'm just going to sign in here and add my Solana wallet, which is this one. So let's add this right here, and let's say Solana. All right, so now we've got both the wallets being tracked, and now you can see it's no longer saying no active wallets to track, because we've got active wallets and it's actually checking the transactions and seeing if there's any swaps being performed by these wallets. And to actually test this out, what you can do is we'll actually try performing a swap. So that's what I'm going to do. I'm in here, have signed in, and if you check the base wallet once, wallet balance ones, you can see we've got USDC. So what we can do is let's try swapping to USDC for CBBTC. And this is the swap we're going to try. So let's review. Let's hit swap here. There you go. And let's hit confirm. So let's wait for this transaction to complete. So you can see that it says it's indexing. All right, now it's indexed. If you go back here, it should pick up the swap pretty soon. You can see it's still processing pending swaps. So let's wait for this to pick it up. There you go. Now it's found one new swap. Its swap fetching is done. It's added it to the processing queue. So now the processor should pick it up soon. There you go. So now you can see it's picked it up and it's actually checking the allowance. It's saying sufficient allowance exists. It's got the 1-inch API. It's done the swap completely, transaction hash. It's all complete. So if you come back to our Telegram now and see the channel, there you go. So now you can see the swap is copied. You can see the original transaction here. And if you click on this and see, you can see our transaction that our bot just did 16 seconds ago. So that's how you can use the copy trading bot to actually listen to wallets and perform transactions. So what we just saw now was for EVM base. So we could do the same and test it for Solana. So I'm just going to head over to Solana as well. So let's go into our Solana. So I'm just going to open up the DEX I have on Solana, which is Meteora. And like we tried last time, let's again try swapping some sol to virtual. So I'm just going to do 0.01 and let's again check the balance to ensure we have got sufficient balance in terms of sol. So you can see we've got 0.07. So this should be completely fine. So let's hit swap here and let's hit confirm now. So this is the wallet. It's all set. And now let's wait for this. You can see view transaction. This is the wallet that we just performed it from. If you go back here, this should actually pick up the swap pretty soon. So it says no pending swaps to process at the moment. As soon as it's available in our API, so if you go back to docs, you can see we've got EVM. This is a Solana, so you just need to copy this address. There you go. And if you hit test live API, we just need to check whether this was the latest transaction. So there you go. So now you can actually see it's found the swap, which means it's now going to get processed. You can see it's executing the Jupiter Ultra swap and it's complete. So that's how fast it actually is in terms of performing the transaction itself. So you can see this was the one we just saw. We've checked the balance. This was the EVM. And now you can see this was the Solana swap. And you can see the time difference between which it picked up the swap and actually executed it. And you can compare both the original transaction as well as our transaction to see the swap that we just did. So if you see right here, we have swapped $1.5 worth of sol for virtual, and that's the same we see right here as well. So that's how easy it is for you to actually use this Telegram bot and get notified whenever the copy trading bot performs transactions. So now we've actually covered almost all parts of building our crypto copy trading bot. So we've seen how you can set up the wallet, your database. We've also gone over the Jupiter and 1-inch docs and all the Moralis APIs that power our bot. And we've actually seen all these areas, including setting up our code base, how you can actually configure various wallets to track, etc. So we have basically built the crypto copy trading bot from scratch. So if you have any questions related to how you can use this crypto copy trading bot or how you can add more enhancements to this, feel free to drop them in the chat. And I'll also link all of the resources that you need, like the GitHub repositories, the Moralis documentation, etc., on the description. So you can directly use this links in order to navigate and try this app out yourself. So the README actually contains how you can actually run this app. So I'm just going to open up the README. And if you check this out, you can see it tells you how you can install all the dependencies, and you can just do first run the initialize script and you'll just start the bot with src/index.js. So if you have any questions related to this, feel free to drop it in the chat. And if you enjoyed this video, give it a thumbs up and subscribe to stay tuned to all our further videos. Thanks for watching. Thank you.